Welcome to G Fun Facts Online. Today, we are journeying to the frozen southern frontiers of the Red Planet to investigate a geological mystery that has captivated scientists for over 2 decades. If you were to view the Martian South Pole from orbit, the landscape would appear white, vast, and scarred. Across the ice, you would see thousands of spindly, black formations that look uncannily like arachnids crawling across the surface. These are known as Martian spiders. They are not biological entities, but they are something almost as strange. They are active, shape-shifting geological features that have no parallel on Earth. To understand them is to understand a violent, alien process where the sun, the ice, and the thin atmosphere conspire to carve the ground with the force of 1,000 geysers. Let us dive into the phenomenon formerly known as iraniform terrain. The story begins in 2003. Cameras aboard NASA's Mars Global Surveyor beamed back high-resolution images of the Martian South Pole. Scientists expected to see ice, craters, and dust. Instead, across the vast South Polar layered deposits, the white ice was interrupted by strange, dark, dendritic patterns. They looked like fossilized riverbeds, or cracks in a windshield, or veins in a leaf. But they possessed a radial symmetry, a central dark spot with spindly legs radiating outward. This earned them the nickname spiders. These are not small features. A single spider can span anywhere from 45 meters to 1 full kilometer across. If you were standing in the center of one, the legs would be deep troughs, potentially knee to waist deep, stretching out to the horizon. They appear in swarms, often clustered together in the thousands, creating a wrinkled, etched texture on the planet's surface that looks like aged skin. What baffled scientists initially was not just their shape, but their activity. Unlike the ancient, stagnant river valleys near the Martian equator which haven't changed in billions of years, these spiders were changing right now. In the Martian spring, dark fans of dust would suddenly appear around them. By winter, they would disappear under a fresh coat of ice, only to re-emerge the following year. This was a smoking gun. The spiders were not ancient fossils, they were being carved today. To understand how a spider forms, we must look at the engine of creation, a theory known as the Kiefer model. This model describes a process that is physically impossible in nature on Earth, called the solid-state greenhouse effect. On Earth, our polar caps are made of water ice. On Mars, while water ice exists, the seasonal caps are composed almost entirely of dry ice, or frozen carbon dioxide. In the dead of the Martian winter, temperatures at the South Pole drop to minus 130 degrees Celsius. The atmosphere itself freezes, depositing a slab of transparent carbon dioxide ice onto the surface. This slab can be several meters thick. This translucent slab is the key. As spring rises over the South Pole, the sun returns. The slab of carbon dioxide ice is unusual because it is translucent to visible light but opaque to infrared radiation or heat. Sunlight passes through the ice sheet like it is a glass window, striking the dark Martian soil underneath. The dark soil absorbs the sunlight and heats up. This heat radiates back upward but is trapped by the ice slab, unable to escape. The result is a rapid rise in temperature at the base of the ice sheet, creating a subsurface pressure cooker. Because Mars has very low atmospheric pressure, carbon dioxide does not melt into a liquid. It sublimates, meaning it turns directly from a solid into a gas. The ice at the bottom of the slab turns into gas, but it is trapped by the heavy weight of the ice slab above. Pressure builds. Pockets of high-pressure gas form beneath the ice, lifting the slab slightly off the ground. The gas begins to flow toward weak points in the ice sheet, scouring the ground as it rushes by. This flowing gas acts like a river, carving channels into the loose soil. These channels form the legs of the spider. Eventually, the pressure becomes too great. The ice slab cracks at a weak point. Boom! A high-velocity jet of carbon dioxide gas bursts through the crack. Shooting up into the Martian sky at speeds of up to 100 miles per hour. This is a carbon dioxide geyser. The geyser does not just spew gas. It carries the dark dust and sand carved from the channels below. This dark material shoots hundreds of feet into the air. As it falls back down, the Martian winds blow it into long, dark streaks across the top of the white ice. From orbit, these look like dark fans. When the summer comes and the ice slab completely sublimates away, the legs carved into the ground are revealed. These permanent scars in the terrain are the areniforms, or the Martian spiders. For nearly 20 years, this Kiefer model was just a theory. No lander had ever visited the South Pole to witness a geyser eruption because the conditions are too extreme. However, in late 2024, a team at NASA's Jet Propulsion Laboratory successfully recreated a Martian spider in a lab for the first time. Researchers used a specialized cryochamber named Dusty. They cooled a Martian soil simulant to extremely low temperatures, condensed carbon dioxide gas into a thick slab of ice over the soil, and simulated the Martian sun using heaters from below. The results were spectacular. The team watched as the carbon dioxide ice cracked and plumes of gas erupted from the regolith, blasting holes in the soil. When they cleared away the ice, they found the signature dendritic spider-like troughs carved into the dirt. This provided the first empirical evidence that our understanding of this alien geology is correct. It also revealed that the ice forms between the soil grains, helping to crack the ground apart from the inside out. Now, where can you find these spiders? They are not found everywhere on Mars. One of the most famous homes of the spiders is a region informally known as Inca City. Discovered in 1972, this area features a geometric network of rectilinear ridges that look like the ruins of an ancient civilization. While the ruins are likely just ancient geological formations, the spiders here are a modern addition. Images from orbit show Inca City dusted with thousands of black spiders, their dark legs contrasting sharply against the walls of the labyrinth. Another major location is the cryptic terrain. This area is peculiar because in thermal imaging it remains cold, indicating ice is present, but it appears dark to the eye. This paradox is explained by the spider activity. The geysers are so active here that they cover the top of the ice with a thick layer of dark dust, hiding the bright ice below. A common question is why we do not see this on Earth. Why are there no spiders in Antarctica? The answer lies in atmospheric chemistry. Earth's polar caps are water ice. Water melts into a liquid. Liquid water flows downhill, carving river valleys and gullies, not radial spiders. Furthermore, Earth's atmosphere is too thick to allow significant carbon dioxide deposition, and our temperatures are too warm for dry ice to form natural slabs thick enough to pressurize. Mars is the only planet in the solar system with the Goldilocks conditions for spiders. It has a surface rich in loose, erodible sediment, temperatures low enough to freeze the atmosphere, and a transparent ice type that allows the solid-state greenhouse effect. The spiders are not static features. They breathe with the seasons of Mars. In autumn, the atmosphere cools and frost settles. In winter, the ice slab thickens, entombing the spiders. In early spring, the sun rises, sublimation begins, and the first geysers erupt. By late spring, activity peaks with thousands of geysers erupting daily. Finally, in summer, the ice vanishes, leaving only the deep scars etched into the ground, waiting for the cycle to begin again. It is crucial to clarify that despite the name, there is no biology involved. The radial branches look organic, like veins or roots, because nature tends to use fractal patterns to distribute energy efficiently. Just as a river creates branches to drain water, the pressurized gas creates branches to drain pressure toward a central vent. Looking to the future, Humans have never landed a probe in spider terrain. The Mars Polar Lander crashed in 1999, and the Phoenix Lander touched down safely but in the north, where spiders do not form. The South Pole is dangerous terrain. It is rugged, extremely cold, and during spider season, the ground is literally exploding with gas jets. A rover driving over a spider could theoretically trigger a geyser, collapsing the ground beneath its wheels. However, future mission concepts propose sending hoppers or drones to these regions. Studying the spiders up close would reveal critical data about the Martian climate cycle. The Martian spiders serve as a humble reminder that Earth-like processes are not the standard for the universe. On a world where the air freezes and the sunlight turns ice into explosions, geology takes on an alien life of its own. These dark, sprawling scars are evidence of a planet that is still geologically alive, shifting, breathing, and carving itself anew with every passing spring. As we continue to gaze down from orbit, the spiders of Mars remain one of the most beautiful and bizarre signatures of our rusty neighbor. Thanks for listening to G Fun Facts Online.